In this demonstration, we will be identifying different types of chemical reactions and also practice writing and balancing chemical equations. So on your worksheet that you have for this, in part 1, this is where you're going to record your data to determine if there was a chemical reaction. And in column 1 on your sheet here, okay, you'll notice it says reactants and then appearance of reactants. So in this column, you're going to write down the formula and the state of matter for each of your reactants along with their appearance. Okay. In the middle column, you're going to write yes or no. Yes, there was a chemical reaction. No, there wasn't. And then in the third column, you'll list the proof. So what did you see? What was the appearance after we combined the two substances together? So in our first experiment, we have copper metal added to hydrochloric acid. So this first tube I've got right here, this is the hydrochloric acid, and you can see that this is just a clear liquid. Okay, I've put the pink behind there to help you identify. Sometimes it's easier to see if there's a reaction when you have something other than a white background. And then we're going to add the copper metal, and so this is what my copper metal looks like. Okay, and then I'm going to add the copper metal, I'll spill a few here and there, to the hydrochloric acid. So when you look, after we've added the copper to the hydrochloric acid, you don't see anything that has happened. Okay, the copper's just sitting there in the hydrochloric acid. Okay, so in this example, we don't have a reaction that has occurred. Okay, so we just write no reaction. And when you're writing this in a chemical formula, you put NR for no reaction. So in our second experiment, we've still got hydrochloric acid. Okay, so this is our hydrochloric acid again, all right? And this time I'm going to add zinc metal, and this is what my zinc metal looks like. Okay, and now I'm going to add this to the hydrochloric acid. All right, so let me see if I can get this a little bit more in focus there for you. So if you look very closely, and if I give this a little shake, you'll notice it kind of gets little fizzies in it. And if you look very closely at the zinc there, you'll notice all of these little bubbles that are present on the zinc. You'll also notice that the zinc is kind of getting darker. It's not as shiny anymore. And I keep getting little bubbles produced. So those bubbles indicate that yes, there is a chemical reaction that is occurring. And they also tell us that there's a gas that is being produced. Okay, so in your reaction column here, you're going to put yes, there was a reaction. And your proof is that the zinc became not as shiny and you got the production of these bubbles. Okay. Now, in our third reaction here, we've got potassium iodide, and I have potassium iodide in my third test tube here, and it's really hard to distinguish, but it's a very, very pale yellow. It's not clear, just like the other liquids have been. It is very pale yellow, and I'm going to mix that with lead nitrate, which is a clear liquid. Okay, so this is my lead nitrate. That's a clear liquid. So I'm going to pour a little bit of my lead nitrate in here with my potassium iodide. So you can see that we do have a chemical reaction occurring. It changes colors, and we get this kind of powdery residue. That's called a precipitate. Okay, that cloudy substance, that kind of powdery substance down at the bottom, that's settling out, that solid there, that's called a precipitate. So we know definitely that we had a chemical reaction that occurred. In my fourth demonstration here, I've got a test tube. This is potassium thiocyanate, clear liquid. And my iron 3 nitrate is kind of this orangey, yellowish red color. Okay. And now I'm going to add that to my potassium thiocyanate. And you see it turns really dark. This kind of red, and if I kind of tilt it so that some kind of comes up on the side there, you can see it sticks to the side. So this has become a lot thicker, okay, and it will start to settle out. So that's my fourth reaction, sorry. And then my fifth reaction, my last one, I have my potassium iodide already in here, so kind of that yellowish, very pale yellow. And I'm going to take my aluminum nitrate, which is a clear liquid, and I'm going to add that to the potassium iodide. And we see it mix a little bit, but no chemical reaction has taken place. So in number 5, the potassium iodide and the aluminum nitrate, this is no reaction. Now on part 2, you're going to finish the word equation. So you're going to have to come up with the products in your word equation, okay? And then in part 3, you're going to convert your word equation into the formula equation and then balance that equation. So your formula equation will need to have the actual formulas for all of these compounds as well as their states of matter. Anytime you get a precipitate or you have the elemental metal like we did with the copper and the zinc, those are going to be solids. Liquid, you look at all of these and you think, well, they're all liquids. The hydrochloric acid was liquid, the potassium iodide was liquid. Those are not actually liquids. The only true liquids that we're going to have are water, elemental bromine, and elemental mercury. Any other time you have a liquid substance that has something dissolved in it, that is called an aqueous solution. And the state of matter for that is AQ. And then we have gases. So anytime we have bubbles that are being produced, our non-metals, our diatomic molecules, those are all gases. So things like hydrogen, H2, oxygen, O2, nitrogen, N2, all of those would have the state of matter of gas. So you'll finish each part of this document and then you'll upload it for the week's assignments.